Welcome to the project demonstration of hardware design of multi-input and multi-output MIMO converter. So in our project mainly we are providing the input from the multi-sources. For our demonstration purpose we are using the solar panel and battery and also grid. So grid is the secondary source to charge our battery whenever the sunlight is not available properly. So here we are using the solar panel ratings of 6 volts 5 watts, 6 volts 5 watts. These two are connected in series. So we will get 12 volt 5 watt DC output from this solar panel. So if you want to charge the battery from the solar panel section, just here we can written the T by S. T for the transformer, S for the solar. Connect the S at this slot, and the next connect this at this voltage sensor slot. So here we have done the S and S after made the connection successfully to this inputs. So now let us see the flow. So according to the proposed block diagram of our project, okay, so in this one, so this is the main proposed block diagram. So here solar panel inputs, the input of the solar panel is given to the battery pack through this electromagnetic relay. Continuously our microcontroller measure the voltages from this source as well as the battery. Whenever the battery voltage is less than threshold value, then the relay gets switched on to allow the power supply from this solar panel to the battery to charge this one. And once it's fully charged, isolate the power supply from the solar to this one. And parallelly the output is given as input to the multi-input, multi-output converter. And next controlling circuit, there's a manual switches to this loads here. So here we are using these three loads. One is the LED indication and CPU fan and DC motors. So these switches are used to control these loads directly, and the power supply is getting from this multi-input multi-input and output boost converter, which is used to drive this power supply to these loads after this battery pack. So coming to this comparison, solar panels and the next relay. So we are using the blue relay here, and battery pack 12 volt 1.5 ampere of current rating we are using, and it's going to be the 18 watts of power can be available from this battery pack. So if you see that there's the three battery packs are connected in series, so we'll get 12 volt 1.5 ampere. Each battery pack is 4 volt 1.5 ampere, and it's a PIC microcontroller. Sorry, here the PIC microcontroller. Instead of this PIC microcontroller, we are using the whole system driven by the STM32. We are using the STM32, the black pill model version board we are using here, and voltage divider circuits. So these are the two voltage divider circuits to measure the voltage, as it will operate with the 5 volts power supply. So in order to measure the 12 volts, we are making use of 10:1 potential divider circuits to measure the voltages of this source as well as our load. And after that, the power supply is given the input to this load, and from there it was distributed to the three loads directly. And this is a breadboard to distribute the 5 volts power supply, which is getting from this regulated power supply board. So this is the regulated power supply board. From there the power supply will be getting input of 12 volts and provide us the DC output of 5 volts. That is the input to this breadboard, and from there we are distributing that to the input output modules of our project. These are charging circuits, look like same, which has the rectifier section. So rectifier will act as a polarity corrector when we provide the solar panel input here. The solar panel input we are providing, and if you want to charge a battery when it is discharged and the sunlight is not available, then directly disconnect this and connect the transformer 2 pins. So this is 2 pin of the transformer. Connect that and on the power supply to this power cable to 30 volts AC inputs, and then it is going to be the normal, right? You can see the light indication on the charging. Okay, so it will take around 5 to 6 hours to be fully charged, either from the transformer or solar panel. So like our microcontroller, which is mainly STM32, which continuously measure the voltage from these voltage sensors, and then after we are going to charge a battery using this relay, and continuously the status displayed on the 16:2 LCD screen. And there's the load switches directly. And here let us place the solar panel, and while we are demonstrating the project in college, directly use the solar panel only, and you can place the solar panels under the sunlight. These are two different solar panels, and which is the same ratings as we discussed, 6 volts 5 watts. And we have interfaced the analog inputs to this STM32 black pill board, and pin numbers to this LCD displays directly interface to that. And here, as we discussed here, these 4 diodes will act as a polarity corrector when we are providing the input from the DC source. But when we are providing input from the transformer, then it will act as a rectifier circuits to convert the AC to pulsating DC, and from there the filter and the diodes which will act as a unidirectional current flow. So this is the main on off switch. So before demonstration, keep the kit under the full charge, then we can provide this. And yeah, we have discussed the multi input, and coming to the multi outputs, these are the 3 loads directly. Just using this switch on and off. Okay, above is the on, and welcome message displayed on the LCD screen. So let us see that. So just we are on and off. Welcome message displayed on the LCD screen, and then after the battery voltage and the solar panel voltage. So if we place external lighting on this solar panel, then automatically the power will be generated from this solar panel, and we can see the voltage is solar panel voltage charging is off. So in order to make the battery low, just we can disconnect this. See, I'm disconnected this, and then and there only the controller unable to measure the voltage from the battery pack, so that the relay got switched on. As you can see, the battery voltage is low, and whenever we reinsert this back, as the battery is fully charged indication, then the battery voltage is 12.79 and solar panel voltage is so in this manner we can get the input of the multiple sources to charge a battery. And also coming to the multi outputs, we can run the multi loads at a time. Right. This is the controlling unit for the manual controlling switching purpose. So we have connected these 2 solar panels in series, so that we will get the maximum power. For convenient to shipping the project, we place the 2 different solar panels with a smaller size one. And this one is a black pill board, and a voltage sensor 1, voltage sensor 2, charging circuit. This one is a charging circuit, and this is going to be the regulator power supply board, which will take the 12 volts input from this battery pack and provide us the 5 volts DC output with the help of this regulator, and that is the input to the total circuits to this breadboard. Okay, and this is the mainly converter which is used to provide us the stable currents while we are controlling the multi output loads. Thank you.